Hey math kids, today we're going to talk about set theory, intersection, and union of sets. So the first thing we should talk about, what is a set? So in our class, we're going to call a set just a group of numbers. We use these curly brackets or set brackets, and so this would be pronounced the set containing 1, 2, 3, and 4. Now we have an operation called union that can tie two sets together. So union looks like a U, like that. So if we have another set, let's say it's 3, 4, 5, 6, this creates a set that contains all the elements of both sets. So 1, 2, 3, 4, 5, and 6. So you're not going to write things that already show up twice. You only write them once. Okay? And so if we draw a Venn diagram, if we called this set A and this set B, this would be A, this would be B. So 3 and 4 would be right here, and then 1 and 2 would be right here, and then 5 and 6 would be right here. So if we're only looking at B, we have 3, 4, 5, 6, like we do right here. And then if we're only looking at A, we have 1, 2, 3, and 4. But union is like an OR operation. So it's saying, what numbers are in A or B? So 1, that's an A or B. 2, A or B. 3, 4, 5, 6. They're all in one or the other. And so that's what union means. Now let's use the same two sets. So 1, 2, 3, 4. And this time we're going to do intersect. 3, 4, 5, 6. And the intersection is just talking about this piece right here, or what they have in common. So this has a 3 and a 4, this has a 3 and a 4, or I guess I should do it right here, 3 and 4, 3 and 4. And so their intersection is a set containing 3 and 4, which on the Venn diagram is that area. So just a couple things to keep in mind. If you have what was I going to say? For something to be a set, it needs to be in curly brackets. So if we have 1, 2, 3, 4, just written like that, that is not a set. But if we put the curly brackets around it, then it's considered a set. Now if we try to do A intersect B, if A is not a set, then you can't do this. But if A and B are both sets, then you can do this, okay? So remember that intersection and union can only be applied to sets. So if you try to apply it to something that's not a set, it doesn't really make sense, okay? Now, I'm going to do a story problem with you, similar to the one on your homework. So let's say there are 400 students, and all of them, let's see, all students take math and gym, or both. 200 students take math, and 250 take gym. How many students take both? Okay, so what we're going to do is we're just going to add these together. So we get 450. Now, we compare that to this. There's 50 that are too many. So if we draw a Venn diagram, we know there's going to be 50 students in the overlap. Now, if 200 did math and 50 are already represented, we just got to subtract that 50 from 200. We get 150 for math. Now for gym, we do the same thing. We subtract 50 and we end up with 200. Now if we look at the entire circle here, see how there's still 250? And if we look at the entire circle for math, there's still 150 plus 50, so it's still 200. And then if we add up the total, 200 plus 50 plus 150, that gives us our 400 student total. And we answered all the questions we needed. So both, the answer would be 50 students, and it also asks us to draw a Venn diagram, and so that works. If you need additional help, please come to Math Lab. Until then, calculator.